welcome back. Our next guest speaker, Professor Marlo Willows, a bioarchaeologist in anthropology at Palomar College, will present Bioarchaeology, Rescuing Skeletons and Telling Their Story.
Hello. Hi. Good morning, everybody. Thanks for being here. So I am a bioarchaeologist, so that's an area within anthropology that merges the methods of both biological anthropology along with archaeology. So I learn about people living in the past by analyzing their skeletons. So an area where bioarchaeologists work is with government agencies like Caltrans, SDG&E, Forestry Services, even armed services, etc. But another big role is with as consultants with private construction firms as well. Depending on the country and the laws, usually construction firms must consult with archaeologists if any material from past people are disturbed in order to make sure that all cultural material is handled with care. I just wanted to say a quick disclaimer that my slides will contain pictures of real skeletons from my research in Scotland through the University of Edinburgh. So if you don't want to view any of that presentation, I won't be offended if you step outside. They aren't showing up. Thank you for letting me know. I think I need to share this again. All right, that should be good now. Okay, yes, thank you for letting me know. All right, so, so sometimes archaeology sites, including material, skeletal material, might be in danger of being destroyed, whether it's because of construction of a road, such as this picture here, or erosion into the sea. So sites and material are literally rescued from destruction. So here is actually a Finnish rescue archaeology with construction that might be impacting an archaeological site. Here's another one from the Links of Notland, which is in Scotland, in Orkney Islands, and that site, erosion poses a real threat there. So they're always, you actually can see it here, they're always trying to make sure that things don't get eroded into the sea. So my work was in Scotland through the University of Edinburgh. An example of one of my projects, what I worked on is an archaeological site in Ballumby, which was located near Dundee on the east coast of Scotland. So this case was also a rescue excavation. The developer was building a new apartment complex when they discovered a burial. So on any project, the first step is to call the police. Then they first have to determine if it's archaeological or forensic. So once it was discovered that it was archaeological, they called an archaeological firm. So the archaeology firm did research and determined historical research from documents and determined that the skeleton was actually part of a burial ground from a medieval church. So the church was actually on an old map. It says here Ballumby. It was on an old map of the region, but they didn't really know exactly where that matched up to the actual ground in Scotland. So they didn't actually know where that was located until the burial ground was found. And so they can match it up with old maps like this one. So as archaeologists, we want to learn all about the people from this rural medieval region of Scotland that there's not a lot of information about. And we want to share that story of that region to the descendants who live in that area who are very curious about their own ancestors. However, the developers, they're on their own time frame, so they're more interested in how long the project is going to be, how long it's going to be on hold, and so they paid for what's called a rescue excavation, which allowed for the removal of the entire cemetery, but they gave them 8 weeks to do it. And of course, this was in Scotland, so the weather does not always behave, so sometimes excavation means literally removing rainwater from the previous day's progress and continuing to carefully remove the skeletons. So we have to be very careful to not damage the skeletons any more than they have been after being in the ground for somewhere around 1,000 years that they've been in the ground. And we also, as we're excavating, we have to remember that this was once someone's grandparent or parent or even child. So we have to treat every skeleton with a lot of respect as you're excavating. And also, as archaeologists, we're all scientists, so we document the excavation with many pictures, diagrams, maps. This is very common, actually, in a medieval cemetery of having multiple individuals in the burial ground because it was very expensive to bury somebody. And so they would often, in medieval churches, anybody within that community that passed within a week or somewhere within that time period, they would be buried together at the same time. So it's not like they were family members or people that were related or possibly even knew each other, but they are buried in the same burial. So that's very common in burial grounds in medieval Scotland. So once the skeletons were removed from the site, they were transferred to my lab at the University of Edinburgh, and they came to be in temporary storage boxes that the developer and part of the excavation, the archaeology firm provided, and they also came to me unwashed. So before you could actually analyze any of the skeletons, I had to wash and organize them. And remember, they had been buried for over 1,000 years. So it meant that the dirt was very compacted, almost solid like concrete. So you have to drip the water on the bones for a while before the dirt would even like loosen and wash away. And you have to do it very, very, very slowly to not damage anything. And of course, it has to be done over trays to make sure that any bone fragments don't wash down the drain. We even had special drains in the sinks that would trap anything that washed down to make sure that it was retrieved, and you can make sure you have all of the pieces. Also, this was cold and rainy Scotland in a cold basement. Of course, they always put archaeology down in the basement, the cold, cold basement. So you're running icy water on your hands for hours at times, so hence why I'm wearing gloves there. And this was a very grueling process that took months, felt like years. So this is where the bones were laid out to dry. These are called drying racks. And it took a long time to dry because the air was very cold and chilly in the basement. So in like a warmer climate, drier climate, obviously it'd be a lot quicker, but this is cold, damp Scotland in a basement, nevertheless. So it also turns out that part of that cemetery was actually a very acidic soil. So it meant that the condition of the burial of the skeletons that were buried there were very poor. So that's what you can kind of see in this picture here, that a lot of the skeletal remains were highly fragmented, and the some parts of the outer layer of the bone has been kind of almost been eaten away by the acidic soil, which does prove to be challenging. So once the bones are dried, I organize them in newer permanent archival quality boxes, and most of these boxes represent one individual. So once I was ready to analyze the skeletal material, I would lay out each individual one at a time, like this is laid out here, kind of, from head to toe. And you lay them out in what is called anatomical position, where all of the bones are in the correct places, the way that an individual would lay if they were still alive. You always make sure that palms are facing up, but that's how you are always laying out an individual. During my analysis, I would carefully examine each bone. I would take an inventory of the skeleton, note the condition of every single bone, take measurements if I could, depending on the condition. This is actually an individual that the condition is very, very good, so I would be able to take specific measurements as well. And as part of my analysis, I would determine the biological sex of the individual, which is also sometimes called assigned sex at birth. It's kind of a new terminology that we're using in forensic anthropology. Also, the age of the individual when they died and how tall they would have been in life. And then also we record any kind of abnormalities, any kinds of disease or trauma that they might have suffered during their life. So on the skeletons, I use both macroscopic analysis, which is visually assessing the skeletons. And I also was able to use microscopic analysis as well, where it included isotopic tests like radiocarbon dating. Also, I was able to do some strontium, oxygen, some different isotopes as well, carbon, nitrogen, some different isotopes as well. So once I analyzed the entire cemetery, I put the analysis into historical context. I wanted to get a more complete picture of what life would have been like for these individuals on a daily basis. So I explored how lifestyle led by these individuals could have affected their health. I also wanted to distinguish which diseases were more prevalent and to see if I could identify any healthcare practices. So to do this, I compared these skeletons with other cemeteries that I also analyzed. So in total, I examined 385 skeletons that were buried in 4 different cemeteries in Scotland. The cemeteries had been excavated either for construction or heritage management. So here's one example of one of the skeletons that I analyzed. This was given the title Skeleton 859 by the archaeology firm. Through my examination, I determined that skeleton 859 was a 45 to 60-year-old male. His right pelvis had a large proliferative lesion. You could see it zoomed in there. And it actually pierced through the bone on both sides. And there was also smaller proliferative lesions, just means like extra bone growth, around the right and left pelvis. And these proliferative or bone-forming lesions are typical of metastatic prostate carcinoma, prostate cancer. So I sent a sample of his bone for isotopic testing and discovered that the skeleton had one of the earliest known cases of prostate cancer in the United Kingdom. And so that was quite interesting results, and this is some of the information that we got from him. The condition, his age, sex, one of the oldest cases of prostate cancer, and this was some of the isotopic results from radiocarbon dating. We have carbon, nitrogen, oxygen, and strontium. So those are some of the isotopes that tell us all sorts of really great information, how old when he lived, but then also types of foods that he ate, types of proteins that he ingested while he was alive, where he grew up, and like where he got his groundwater that he drank, and also the soil that his food grew in as he grew up. So it tells a lot of really good information. They actually use some of that now in forensic cases where they're trying to find missing people, and they are trying to identify. So they're using some of those isotopic. We've been doing it in archaeology for a long time, but now they're actually applying it into forensic cases now, which is really quite amazing to try to find individuals that they don't have any other information to identify them with. So I also researched what historical documents said about health and disease in medieval Scotland by collaborating with medieval historians. Through my skeletal and isotopic analysis, I made a lot of discoveries about individuals that lived in medieval Scotland. A few of those were that there were a lot of differences between individuals that lived in rural and in urban versus rural locations. There were also differences in health between people that were buried in the monastery cemeteries, the monasteries versus a non-monastic, a lay community, which would also have been tied to their social status, because the more wealthier individuals could afford to be buried in a monastic cemetery because it cost money to be buried there. But they wanted to be buried there because they're in medieval Scottish church. You could go to heaven a lot quicker if you were buried there. So you pay money to be buried there. So there was some really interesting information that I could get by comparing those cemeteries. So as a scientist, once I made those discoveries, I shared my findings with others in my field through peer-reviewed articles and book chapters. And so these are some of the various ones that I collaborated and was able to publish. And then also, as a bioarchaeologist, it's important to share the findings with all interested parties. And so I shared my research with various organizations, including universities, historical societies, museums, local government officials, and other bioarchaeologists. And some of the people that I shared my discoveries with might have actually had ancestors buried in the cemeteries that I analyzed. So they got to, really share in their family's history in a very real way, learning about the lives of their ancestors. Some of these sites would actually have the neighborhood individuals where the sites were near. They would come and ask questions for the archaeologists about the site and what they're finding, and they're very excited about finding out information about. So some of the archaeologists would have small little talks here and there to try to inform the community, and so it was really important to be able to share that back to the community in these various ways, because they were very interested and very excited to learn about their ancestors in this way. That is, I'm done with. And so if anyone has any questions.